Hello and welcome back to Programming with Python. Today I would like to talk about loops, comparison and logical operators, and conditionals. But before doing so, let me first discuss a set of rules which I call the 10 Commandments of Programming that I believe might help you to become a better programmer more quickly. What are these rules? The first one is really quite obvious. It tells us that we should first think about the problem and we should specify exactly what we want to do before writing any code. On my desktop, I have a notebook of this type and a pen, and what I do before solving any problem is I write down exactly the expectation, what I want my program to do, and I think about small steps that I need to do in order to solve the overall problem. This also relates to point 2, which I call expectation. Some programs and problems in general can become overwhelmingly complex. It is very important that we first break these problems into small independent blocks and specify exactly what we want each block to do. Okay, it's very important to write down the expectations. If I give this input to my code, I would like to achieve this output, because this will also help you later on to test your code to see if it actually fulfills the expectations you set out at the beginning. We should have an organized working style, so whenever we start a new project, we create a new folder maybe on our computer's desktop and we put a fresh Python file in that folder. And also we should think about good names for files. Don't call your computer codes code1.py, code2.py. Give them some names that are meaningful so you can later find easily what you have done previously. The fourth point is referred to as work inside to outside. What this means is that we always start with solving the core functionality of a block that we have specified. Remember, we break our program into small independent blocks. We specify exactly what we want each block to do, and then we start by programming the core of each of the blocks. Okay. It's very important that we first start with the most important part of the problem, and then we work from inside to outside. It will become clear when we look at some examples later on what I mean by that. It is good to always start with a rough version of a code, and only when you have this rough version working and satisfy your expectations, you then refine it and extend it. The fifth point, use the internet. So Python is a very popular language, in fact one of the most popular programming languages, and there are a lot of people out there that had potentially exactly the same problem that you want to solve right now. So if you Google Python how to sort a list, it is very, very likely that you will find a solution to your problem rather quickly. The sixth point related to that, once you found the solution on the web, do not just copy and paste, right? Because you don't learn anything by copying and pasting code from the internet to your editor. And actually it will make it much more difficult for you later on to debug your code, because you will have lots of stuff there that you don't really understand. So I would recommend, once you find a solution on the internet, understand the main idea of that solution and then write your own code. Okay. Verification, point number 7. It is important that we test our computer codes, and I recommend doing this, at least in the beginning, line by line. Your computer actually does exactly what you tell it to do. So if you write a computer program and it behaves differently from the expectations that you have defined in step 2, then it is likely our own fault, right? So I recommend writing maybe one line of Python code, running the code and seeing what it does. Okay, if it works fine, you can add the second line and so on. And what is good with this approach is that if you edit a line that suddenly breaks your code, so it doesn't behave as you expected anymore, then it was likely the last line that you added. This also refers to point number 8, read Python error messages. In the Python window, in the Spider editor window, you will see Python error messages coming up. And if you read them very carefully, they can be very useful in order to pin down what exactly was the problem in your code. Always put meaningful comments in your code. We have talked about comments already. It just means that when you write a piece of software, you want to make sure that someone who is not familiar with your code should be able to use it. In fact, it's a bit harsh to say, but in some sense, code without any documentation is useless, right? So the documentation is almost as important as the computer code itself. And finally, and maybe most importantly, be proud of what you achieved. Okay? If you have written a nice computer program that does something interesting, maybe you can share it with others. Have a look at GitHub. Okay, that's a website you can look into where people actually share their computer codes to the community. And it will help you also to create a public profile. So if you have maybe completed a coursework project at the end of this code, you might consider putting it on your website or on GitHub, and you can then add this maybe to your CV as some kind of demonstrable experience with Python programming later on. Be proud of what you have achieved. So let's talk about loops. It is rarely useful that a computer performs a task or operation only once, and in fact computers are very good at repeating the same calculation over and over again. And in order to do this, we need loops. The most common type of a loop is called for loop, and it is usually used to execute some part of a code in a predetermined number of times. What this means is we will likely want to use a for loop, if we know in advance that we want to repeat a certain task, let's say 5 times. The way we do this in Python is to use the so-called for keyword in combination with the range function. The range function pretends to return a list of numbers. I say pretends because actually it returns an iterator, and we will talk about iterators later on, but for the moment you can think about the returned value of a range function as a list of numbers. There are 3 ways you can call the range function, with 1, 2, or 3 input parameters, and it is specified here what each of these cases does. I think it is most instructive to actually look at an example, and you will see what is going on. So here is a short piece of code, which I'm going to copy and paste into my Spider editor, just to show you, referring to the 10 commandments from the beginning, the point about making a clean working environment. I have created on my desktop folder called Python, and in this folder I have a subfolder called week 2, and the current program I'm writing is called loops.py. Okay, so this will help me later on to find exactly what I've done in week 2 of my Python course, and I can actually reuse some of the code that I've written. So let's copy and paste this simple for loop into the editor. You notice that we have here the for keyword. This is a keyword in Python. You see it highlighted in blue, so it's a special command. Then we have a variable name, in this case I. Okay, so the variable I'm working with will be called I. You can use any name here. Okay, so it can be your variable. It doesn't matter, it's a variable name. Then we have the in keyword. Again, you see it highlighted in blue. And then the range function that I mentioned before with just 1 input parameter. So what happens here is that this range function will now return a list of integers. Most importantly in Python, when you have a command like that expects a block of commands later on, we end it with a colon like this. And on the next line, we have an indented command, in this case, print hello world. Okay. Let me just run this code and see what happens. Here, when this window opens the first time you run a code, make sure that you select execute in a dedicated console, and also tick remove all variables before execution, and then hit run. Python now connects to the kernel, and there we go. So what do we see here? Well, we see hello world being printed 5 times on the command line. Well, this probably has to do with the fact that we have called the range function with the input parameter 5. Let's maybe change this to 3. As we expect, hello world is now printed out 3 times. Instead of just having one command that is repeated 3 times. Can I have more than one command? Of course you can. So you can have some other print command here, or anything you like, in fact. Some other text. And when you run that, of course it will now repeat these two commands, these two print commands together. And you see, this is how it works in Python. The indentation tells us what block belongs to the for loop. If I move this print command to the same indentation level as my for command, and I run that code, it will only print hello world 3 times, finish the for loop, and then move on to the next line here and print some other text only once, because it's no longer part of the for loop. So if I want this to be in the for loop, I need to indent it using the tab key on my keyboard. Now, what is this variable name for? Well, it turns out that I can use this variable name in the loop. So let's just use it, and I'm gonna print it out. Okay, so it should now print hello world and then the name of the variable as we go through the for loop. And you see this here. So we have printed hello world, and then we have printed 0, hello world 1, hello world 2. So this shows that the integers returned by the range function start counting at 0 and they end at 1 less than the number we specified here. Okay, so it will repeat 3 times, but it starts counting at 0, hence the variable values are 0, 1, and 2. In order to make this a bit shorter, I'm gonna change back to the variable name I, and I'm now only going to print out I. Now we can explore exactly what happens when we use more input parameters for the range function. So what if I call range 3, 7? Well, let's try it out. Okay, it prints out 3, 4, 5, 6. So the range function starts counting at the first argument and it ends counting at the second argument -1 if you call it with 2 input parameters. What happens if I use 3 input parameters like 3, 7, 2? Well, now I start counting at the first input parameter, which is 3, and I keep incrementing values by 2. So 3 plus 2 is 5, and I will stop when the value of the range function is just 1 less than the end value here. In order to see this maybe a bit clearer, let's put 15 here. And what it will do now is it will start counting at 3, go up to 15 minus 1, which is 14, in steps of 2. Of course, 14 is not included because I'm only counting here starting from an odd number. So 13 will be the last integer value that is returned. We can also use this for counting backwards. So if I want to count from 15 down to 4, remember now this is not included, this is not the included int value, I can go back in steps of -1. This is the use of the range function, and you see I can use this to repeat any piece of code that is indented into a block as often as I like. Now it's also specified in mathematical notation what the range function does, but I think, I hope you get the idea by just looking at this example. Now this helps us a lot, right? Imagine I wanted to print out hello world 5 times, then if I would not have a for command, I would have to do something like this. Assign the value I being 0, print out hello world, assign the value of 1 to I, hello world, and so on. Now sometimes we actually just want to print out something, let's say 5 times, like so, and I don't really need the value of I. Then I can replace it with the so-called throwaway variable, which is an underscore in Python. Okay. Does exactly the same thing, but now I will not have the value of I at my disposal within the for loop. Okay, to summarize, that's actually all you need to know about the for loop. The definition of a for loop starts with the keyword for. Then we have the variable name, which was I, or your variable in my example. Or if we don't need this variable, we can just put an underscore there. Then we have this in keyword, and then a list or something that acts like a list, which specifies the range, and that's always important not to forget, a colon that ends the definition of the for loop. And as I mentioned before, indentation is very important. Everything that is indented following this colon will belong to the block spanned by this for loop. Let's discuss a useful application of the for loop, just to get a feel for what we can do with it. Let's say we have the following problem. We want to write a program that inputs an integer n, and then asks the user for, let's say, n numbers, and prints the sum of these numbers, s. Okay, very simple task, like a simple calculator. How would we do this manually? Well, we would first ask for how many numbers do you want to add? Okay, let's say 5. And then we would like to form the sum here. Now in programming, it's always good to start thinking first about how do you actually form the sum. If you want to add up 5 numbers, well, the way you do this manually is you add up the first number to 0. Then you add the second number to the previous sum. Then you add the third number to the previous sum, and so on. Right? This gives already an idea of how we would actually form this value s. We would start with the value s being equal to 0. That's the initial value of a sum. Then we would ask for a number, which at the first instance would be a1. I call it x here. And then we add this number to our running sum s. After we have done this, we have added the first number to 0, but we want to actually add n numbers. So we will repeat steps 3 and 4. We need to ask for the next number to add. We will increment our sum s. We will ask for the next number to add, and so on. And this should be repeated n times, right? Because we have n additions to do here in order to sum up these n numbers. And then the output of the algorithm, of course, is the sum s that we want to produce. Now we can rephrase this a little bit as a 4-step sequence. Input the value of n, set this value of s equal to 0, and then repeat the following steps n times. Get the next number x, add x to the sum s, and repeat. Print the result s. Here is a Python implementation of this algorithm, and I'm gonna just try it out in Spider. But first talk about it briefly. So recall from last lecture, we have learned about the input function, which can take some input argument. So this will print out on the console how many numbers do you want to add up. Now remember, the input function itself always returns a string. So in order to treat this as an integer n, we need to explicitly convert it using the int function. And the int function will then return a value that is indeed an integer, which we call n here. The running sum is called s here, and we initialize it with the value 0, because if we haven't added up any numbers in our sum, then the value of that sum is defined to be 0. And here you see our for loop. For variable name in range command, and we have n repetitions of the same code following the colon command. And this is the block that we want to repeat n times. What do we do here? It looks complicated, but let's break it down, always starting from the inside to the outside. Well, inside of this line here, we have the input function, and it will output a string which says input a underscore, and then i+1, which is the value that the for loop traverses. The result of the input function, again, is a string. We cannot really add up strings to form a sum, so we need to convert it into a floating point number. Remember, the user might not just add integers, they actually might want to add up floating point numbers, so we need to convert it to a floating point number using the float function, and the value that we are inputting will then be assigned to the variable x. And here we increment the value of s by the value of x. Now if you repeat this n times, you will actually input n numbers, and you will have computed the sum of these n numbers. So once this is completed, we want to then print out the value of s. So let's run this. How many numbers do we want to add up? Well, let's say 4. Okay, I have now assigned the value 4 to the variable n. My for loop already started, and I'm now executing this line here where it's printing out input a1. This is produced by this string here, and I can now say, okay, my variable a1 or my value of a1 should be 2.61. Input a2, let's say minus 3.4, and finally input a3. Not finally, we actually have 4 numbers. That's 1.2, and let's also include 0 here. Now this is the last time the for loop is executed because n is equal to 4. So when I hit enter, it should now jump to line number 8 here, which will print out the sum that we have computed. 0.40999999. And you already see here an interesting effect of floating point arithmetic. The exact result that we would expect from these inputs is actually 0.41, but it's not exactly 0.41, but it's something very close to it. Now you see that in our string that we form here, we take the variable I, which is used in the for loop here, we increment it by 1 and we convert it to a string. We do this because we can only concatenate strings using the plus operator. Right? We cannot do this. If this was an integer here, we would get an error message. Now this is maybe a bit difficult to read, so we can in fact simplify this by typing string I here and then have the for loop start counting at 0. Okay. The reason why it was I plus 1 here is because for loops in Python always start counting at 0. So if I want to print out a1 in the first iteration, I had to increase this value by 1. But if I actually change the for loop to start from 1, then I don't need this increment here. However, we now need to remember, if I start counting at 1 and I want to input n numbers, I need to have the second parameter of the range function to be n plus 1. Because the last value is not included. So this should work. I want to add up 3 numbers, 1, 2, 3, and indeed the sum of these numbers is 6. We don't always know in advance how many repetitions of a block we want to perform, and for this purpose we have while loops. You can think of a situation, for example, thinking back to our sum computation, where we ask the user first how many numbers they want to add up. You can think of a situation where we tell them, well, you can enter numbers as long as you like, and we will compute or we will return the sum that you want if you enter the number 0. Right? So in this case, we don't know in advance how many repetitions will be performed, and therefore we need something else than a for loop. Now what we need here is a while loop, and I demonstrate the use of a while loop at a simple code example, which I copy and paste. Let's walk through this step by step, or rather line by line. In the first line, we will get an integer value from the user, call it n. In the second line, we define a variable I, which we initialize with the value 0. This is like a running variable. This variable will be used to keep track of how many iterations we have done with our while loop. And here on line 3, you see the definition of a while loop. It always starts with the while keyword, followed by a condition, which is either true or false. This is a Boolean condition. In this case, a comparison between the values of I and n. Right? So, for example, if I enter the value n being 5 here, I is 0 as we have defined, then the condition checks whether 0 is less than 5, and that's something that is either true or false. If it is true, then we will enter the body of our while loop, which is everything that follows the definition of the while loop and is indented to the same level. You see the print command and this line here, they are both indented using the tab key, so they belong to the body of the while loop. Also remember that after the condition of the while loop there is a colon, just as was the case with our for loop that we used before. What happens inside the while loop? Inside the while loop we just print out the value of I and we increase the value of I by the value of 1. And then what happens is Python will jump back to this line here. It will now check this condition again with the new value of I, of course. If it is true, it will execute the body of the while loop, and so on. Okay, so this keeps on repeating what is inside the body of the while loop, and it will only stop when, after coming back to the top here, the condition is false. So let's try this out. I will choose a value of 5 for n, and as you can see, it's just repeating these print commands and increment commands 5 times until the value of I is incremented to 5. Now, when is this condition here actually checked? It turns out it is only checked at the beginning of the while loop. If the value of I happens to not satisfy this condition inside the loop, that doesn't matter. Okay, this body will still be executed till the end. I show you what I mean by this using a simple example. So let's change our code so that we write here print before I will output the value of I. I will then increment it by 1, and I'm also going to print it after the increment. So what we should see now is that in the first iteration, when I is 0, it will print before 0, it will increment the value of I by 1, and it will print after, and it should now be 1, right? It will then go back here, it will check the condition, it will then print before 1, increase the value of I by 1, which is 2, and print out after 2, and so on. Let's run that. Again, I choose n equal 5. And here you see what happens. As expected, it prints before 0 after 1, before 1 after 2, and so on and so on. And what is interesting here is that in the last iteration, it prints before 4, right? So I now takes the value of 4. It increases the value of I by 1, so that it prints after 5. It will then go back to the header of our while loop. It will check, is I having the value of 5 less than 5? No, right? That's a strict comparison here. So this condition will be false and the while loop will stop. But you see that inside the while loop, it still has actually attained the value of 5 and printed out the value after the increment. So the condition that we have here is really only checked when Python comes back to the header of our while loop. It might actually be false inside the block. So just a quick recap. We have learned about the while loop. It is used by starting with the keyword while. Then we have a Boolean condition that has to be checked, followed by a colon. And then everything that follows this definition and is indented to the right level will be part of the while loop's body. And as I mentioned before, this is very important. The condition that we use for stopping our while loop is only checked before the execution of the body, and only then. And this is here basically the same example that I just developed with you in Spider. Can we change how loops run? Yes, indeed, we can actually continue loops and we can break them, but we will learn about this later when we talk about control flow in more details. It is now time to talk about comparison and logical operators, because these are the ones we use when we define while loops, but we might also use them in other parts of our code. We have already seen this comparison operator here, which just checks if the value on the left is smaller than the value on the right. You can also look for a condition of this type, where you have that A is smaller than or equal to the value of B on the right. Of course, you can check if A is bigger than B or bigger than or equal to the value of B. It's important that you have the right order of these symbols, so don't swap them. It's always first the inequality and then the equality operator. And the way to remember that is as it is written in English, so A is bigger than or equal to the value of B. So the inequality comparison comes first. If you want to check whether two values are the same, equal to each other, then we will use this double equality operator here. Now, why is this a double symbol? Well, because the single symbol has already been used in another context. Remember, that's what we use for assigning values to variables. So in order to check for equality, we need another symbol, and in Python it is this double equal operator. If we want to check that two variables do not have the same value, we use this exclamation mark equal notation here. And there are some other operators. We will talk about is later on in the course. If you want to check that A and B are exactly the same object, we use A is B. And if they are not exactly the same object, we use A is not B. And then we have logical comparisons like OR and AND. Okay, so if either A or B has the value true, then this comparison here will return the value true. And of course there's AND, which gives true if and only if both A and B have a true value. It should be noted here that both A and B can be non-Boolean values, and we will see in a bit what actually happens in this case. The negation in Python is done with the not A keyword. Here is a side remark. If one is checking whether a variable x is undefined, in which case it takes the value none, we will always use the notation x is none or x is not none, and not x is equal none, right? So that's the comparison we use, for example, if we check the two numbers have the same value. But if you want to compare something with the non value, we always use the is keyword. Okay. The details of this are quite technical and beyond the scope of this course, but it's just important to remember that we use is when we want to compare something with none and not the double equality operator. So here's a short code that demonstrates this in action. If I type 1 less than 2 in Python, this is a Boolean expression that can be evaluated to true or false. In this case, it will evaluate to true and therefore also print out true here. Whereas if I check whether 1 is strictly less than 1, certainly that's false, and it's also printed out here, as you can see. Now it's important, just a reminder, Boolean values in Python are always with capital letters, right? So capital T and capital S for both true and false outputs here. Now it is also possible to combine these comparison operators into single expressions, which are called composite comparisons. You can type A less B less C, and this will be a shorthand for A is less than B and B is less than C. Or you could type A less B greater C, which is a shorthand for A is less than B and B is greater than C. And these will evaluate again to true and false. Personally, I find these shorthand notations not very easy to read, and I would always prefer to write them out in full form, right? This is something that is very easy to read. A is less than B and B is less than C. Whereas here I always have to think twice, remind myself what is actually meant by this notation. So personally, I avoid it, but it's completely up to you. It is also possible to have more than 3 of these expressions. You can have an arbitrary number, and they're always checked from left to right and then combined with AND, as we have seen above here. Another reason why these comparisons are not very nice, in my opinion, is that they behave very differently in different programming languages, right? So if you want to port a code from Python to, I don't know, MATLAB, for example, you might find that these comparison operators will behave differently. Another reason to not use the shorthand notation, at least in my opinion. Just a quick note on equality and inequality operators, as they ignore the types of variables to a certain extent. It is perfectly valid in Python to have a comparison of this form, where we compare the value false, which is a Boolean value, to the value 0, which is an integer value. Now this comparison indeed returns the value true, and you can easily try this out in Spider, for example on the console. If I type false has the same value as 0, then the output will be true. Okay, so this comparison evaluates to the value true. While if I check if false has the same value as 1, this will be false. However, true, the Boolean value true, is logically equivalent to the integer value 1. Okay, this returns true here. While true is not logically equivalent to the value of 2, returning false here. We have just learned how, using while loops, we can execute blocks of code repeatedly depending on a stopping condition. Now, very often we just want to check if a condition is true and execute a block of code only once based on the Boolean value of this condition, or maybe we want to jump to another branch of our code, and this is done using conditionals. Okay. A conditional is created with the if keyword in Python, and there's also an else and elif keyword that I will show you now. It's best to look at an example in order to understand how to use if keywords. So let's say we have an integer variable n, and I will give it the value of 5 for now, and we want in our code to verify whether this is a negative number or a non-negative number. So let's start with the first bit. How do we check whether n has a negative value? Well, we use a Boolean comparison of this form, right? Clearly, n less than 0 evaluates to true if n has a negative value. Now, the if keyword in Python is just used as follows. If Boolean condition colon, just as with the while loop and the for loop, we have a colon after our comparison. And now we put in some code here. So let's say if n is less than 0, I want to print out negative. That's it. So this defines a simple if command. If this condition evaluates to true, Python will jump into this block and execute it. Let's run this. And you see that we don't see any outputs here, right? Which is clear because n takes the value of 5 in our code. Therefore, this comparison here evaluates to false, and so we are skipping this block. If I assign a value of minus 2.3, let's say, to n, and I execute again, then now it will execute this print command because this condition evaluates to true. Now let's say in the case that n is not negative, we want to output something, so we use the else keyword for that. Non-negative. So I now have two branches in my code. The first branch is here. When this condition is true, I will execute all the block that follows the if statement. If this condition evaluates to false, I will jump to the else part of my code and execute this part. Right? So let's see what happens. For n having the value of minus 2.3, I'll jump to this branch, which prints out negative. If I use a positive value here, it will jump to the else part and print out non-negative. Okay. That's the basic use of if and if-else combinations. And you can have if-else blocks within both the if part and the else part. So let's say we want to be a bit more specific here. We want to check if n is non-negative. We want to also check if it is positive, in which case we can more specifically print out positive. Or otherwise, it is a number that is neither positive or negative, could be 0, but I will be on the safe side here because maybe we are not dealing with integers, so I will just type something else. All right, so let's run this code. If n has the value 2.3, then this comparison here evaluates to false. Therefore, we will jump to the else block of our code. In this else block, we have another if-else comparison. We check if n is greater than 0, which in our case is true. Therefore, we will jump into this block here and print out positive. Now, if I run this with n equals 0, it would again jump into the else block here, but this condition would be false, and therefore we will print out something else. Let's verify this. And that's indeed the case. There is a shorthand notation for nested blocks of this form. You can in fact contract else and the following if command into elif, right? That is equivalent, and it saves us one of the indentations, because we can now write something like this. This would be a completely equivalent code to the previous one, but it saves us one indentation level. To be very clean, this should also be on the same level. Just a quick note that it is possible in Python to use the else keyword in conjunction with loops. Here are two examples. I have a while loop which has in it an if condition that is being checked, and then following the while loop I have an else block. This is to be contrasted with this piece of code here, where I have a while condition, and then inside my while loop I have an if-else block, as we have just discussed. Now it turns out that both of these are valid Python code. They will not report any error, but they will behave differently, and this can cause some confusions, and it shows that in Python indentation is extremely important. Most likely what you really wanted is the second version here. You have some while loop, and inside your while loop you have an if-else comparison. So be careful that you use the correct indentation levels in Python. If and else should be on the same level of indentation, using the tab key usually. Let's look at a slightly more interesting example where we demonstrate the use of if and else. Let's say we are given two variables a and b, and our task is to find which one is the minimum and which one is the maximum. And we want to assign the values of these variables to new variables called min value and max value respectively. Here is a piece of code that does exactly this. Let's try it out. First, go through it line by line to understand what we are doing. So we start by loading a floating point value for the variable a and a floating point value for the variable b. We have seen this before. In fact, I will remove these inputs for now, and this is something that you should consider doing as well in the future, because inputting values for a and b is not something that we consider to be the core of the problem, right? The problem we want to solve here really is to assign the min and max value of two variables, and to compare these two. We don't really want to deal with the inputs of the user, at least at the beginning when we develop our code. So what I'll do is I'll just pre-assign fixed values for testing. So let's say a is 3 and b takes the value 7. And we first focus on the core of the problem, which is this one here. This if-else command is really the core of our code. So what are we doing? Well, we check whether a is less than b. If this is the case, we know that a holds the minimal value of the two, so we assign the value of a to a new variable called min value. Likewise, b will hold the maximum value, so we assign it to a new variable called max value. If this condition is false, then we know that b is less or equal than b. Therefore, we will say that the min value is what is being held in the variable b, and a is assigned to the max value. And well, we don't need to print out a and b because we can see it right here in the code. Once we have done this assignment, we can print out min being the min value and max being the max value. So let's run this piece of code. And as expected, it has assigned the value of 3 to the min value variable and the value of 7 to the max value variable, because we have executed this branch of the code and we have skipped this branch of the code. I can try something else. So let's say b takes the value of 1 and a takes the value of 2. Now the two variables should be swapped. And as you can see, it has identified correctly that the minimal value is 1 and the maximal value is 2. Now Python has, of course, many functions that make things like this much more convenient. In fact, there is a min and a mux function available. So if we type min and then give it 2 input parameters, it will return as the value the minimum of the 2 values. And there's likewise also a mux function which we can use. So this program is completely equivalent to the previous one. Let's try it out. Minimal value is 1 and the maximal value is 2. This would be considered to be a more Pythonic solution to a problem, right? So problems can always be solved in a very detailed and long way. In Python, there are many shortcuts you can use to solve a particular problem, and these shortcuts are often referred to as Pythonic solutions. You are not expected in any of the exercises or in the coursework to use very Pythonic solutions. You would be perfectly fine using the longer if and else comparison that we used before. Here is another example. Let's say we want to load values of a and b in a way that we make sure that a is always less or equal than b. Now let's have a look here. We have again 2 inputs for floating point values of a and b, and the following would be wrong. So let's say we want to now swap a and b because a happens to be greater than b. Then what one might do in the first instance is to say, okay, I want a to take the value of b and I want b to take the value of a. However, this is wrong because by doing so, you would first assign the value of b to a, but at this point you will have lost the previous value of a, because remember, a variable can only store one value at a time. So here we have overwritten the value of a with the value of b. So when we make this assignment here, we basically reassign the same value of b to the variable b again. So at the end of this block here, both a and b will have the value of b, and we have not really swapped them. We want to swap these values. So how do we circumvent this problem? Well, we cannot actually swap the values of 2 variables without a third variable. So this is the solution to the problem. Let's say a is greater than b, so we want to swap their values. What we do is we remember the value of a in a temporary variable tmp, called here. We can then use this variable a to assign the value of b to it. Because we have remembered the original value of a in this temporary variable, we can use it to assign this corresponding value to b. Let's have a look how this works in practice. Okay, running. Let's say I enter a value of a which is 7, and I enter a value of b which is 4. Now I want to swap them because I want b to be greater than a. And as you can see, this has happened, right? We have now reassigned the value 4 to a, and we have reassigned the value of 7 to b. And you can see in the variable explorer that indeed the temporary variable tmp has taken the original value of a, which was 7, and that's then what we used for the assignment of b. Again, there is a more Pythonic solution to doing this. In fact, this code here could be replaced by this code. Take b and a and assign them to a and b. This would swap the values of the variables a and b. We can run this. It does exactly the same as before. Again, this is a Pythonic solution and you are not expected to use it at this stage, but later on in the course we will understand exactly what is going on here. Now here is a very important problem that we need to understand, because it will be part of many of the exercises and assignments that will come up in the next weeks. Let's say we want to compute the digits of a number, or more precisely, we want to find the sum of a given number's digits. Now, when we read this, maybe we don't have a full understanding yet of what we actually mean by this. So let's first think about an example, get the expectations right. So if I consider the number 123, let's say, what would I expect to get out here? Well, the sum of the digits of the number 123 is 1 plus 2 plus 3, right? So I would expect an output of 6 because this corresponds to the sum of the digits. Now, how do we get the digits of a number x in Python? There is no command that tells us get the second digit, get the first digit. We need to somehow extract the digits by ourselves. And it turns out that this is very easy using the arithmetic operators that we have previously learned, namely the modulo and the integer division operator. Let's look at this example where we get a number x and we play a little bit with these two operators. Again, I could input this number from the user, but actually, in order to save a bit of time, I will do this with a fixed number x, let's say 1, 2, 3. So recall what this operation here meant. This is the remainder after division by 10, right? So what is the remainder after division by 10? Well, that would be 3, because 120 is divisible by 10. Right, 120 divided by 10 is 12, and the remainder is 3, which happens to be the last digit of that number. And this here is the integer division operator that we have seen before. This will just divide the number by 10 and only keep the integer part, which is 12. So if I run this, you will see that indeed we have extracted the last digit of 1, 2, 3, which is 3. And we have chopped off the last digit and be left with 12. Now this is great because if I can get the last digit of 1, 2, 3 using this piece of code, I can get the last digit of 12, which is the number with the 3 removed, and this will then correspond to the second digit of the original number, right? If I execute this with x being equal to 12, I have now extracted the second digit of 1, 2, 3, and I can repeat this over and over again. I can repeat this with x having the value of 1. I will get the last digit of 1, which is 1, and then I'm left with 0. So by successively chopping off digits from the end of the number, working my way to the front, I can get all the digits one after the other. Now, how do we compute the sum of all the digits? We certainly want to use a loop for that, because we don't want to do this manually, one digit after the other. So what type of loop should we use, a for loop or a while loop? Do we know exactly in advance how many iterations we want to do? No, because the number x could have 3 digits, it could have 6 digits or 8, right? So probably we want to use a while loop. Now, if we compute a sum of something, we need a variable that stores that sum, as in the previous example of the sum of digits or numbers that we have considered. And this variable should be initialized with the value of 0. I will call this variable s and initialize it as 0. Now, when do we stop chopping off digits from the end of our variable x? Well, we can stop when this operation here has resulted in 0, right? So if the variable x takes the value 0, we have no more digits left and we can stop our while loop. So our stopping condition for the while loop should be like this. While x is non-zero, what we want to do is we want to get the last digit, and the last digit of that number x is obtained using this operator here, okay, remainder after division by 10, and then we will remove the last digit from x by using integer division of this form. Now, what do we do? Sorry, this should be an x here, right? So we will extract the last digit from x and assign it to the variable d. Now, this variable d stores the last digit that we want, and we can increment s by this variable d. And that's it. So after this while loop is completed, we can print out the value of s, and it should indeed store the sum of the digits in x. Let's try it out. Okay, the answer is 6 using this input here. Let's try some other numbers. 1, 2, 3, 4, 5. 15. This is indeed the sum of these digits. In programming, it is always important to check all the possible cases that could happen, in particular boundary cases. So what if I run this code with the value of x being 0? Okay, let's see. The sum of the digits in 0 is 0, and that's fine. And the way this works is because I have initialized the value of s to be 0, if I run this code with x having the value of 0, this while loop will of course not be executed, and I'm printing out 0 immediately. So this is fine. Let's try something else. Let's take a negative value. What about the value of minus 170? Oh, for some reason, I don't see any output, but actually my code is running, and you can see this by this red square here. So what I need to do now is I need to stop the execution of this. I'm stuck in an infinite loop. If you're curious why our code does not stop, you can consider putting a print command here, printing out the value of x at each iteration, and see if it actually attains the value of 0, which is our stopping condition. Okay, let's run this. And you see that we are somehow getting stuck at a value of x being minus 1. And it will never stop doing that. And the reason for this behavior is that what we have done here, extracting the last digit of a number, does not work for negative values of x. Take, for example, minus 123 and try to extract the last digit using this division operator. You will get 7 and not 3, because this actually goes down to minus 130, which is divisible by 10, and the remainder, the positive remainder after division by 10 is 7. Okay, so this does not give us the last digit 3 as we expect, but it gives us the last digit or the value of 7, which is certainly not what we want. So in order to fix this, we need to somehow get rid of this minus sign here. And one way of doing it is to simply just reassign x with its own absolute value. So if I now run the code, I will get 17, 1, and 0 as my outputs for x. And the last number that we print out is indeed the sum of the digits, which is 8. I can now get rid of this print statement here. Right? So the sum of digits of minus 170 is indeed 8. Now that we have solved the core of the problem, compute the sum of the digits in a number, we can refine our code. We can make it nicer. So first of all, maybe we want to have the user enter the number x instead of us predefining it in the code. So we could use int of input and then say which number do you want to enter, let's say. Okay, so they input an integer value. And maybe at the end of our program, we want to output the sum of digits in x is s. Right. Now there's a small problem. If the user enters minus 170, then we will change this to plus 170. And then indeed, at each iteration of our while loop, we will chop off one digit from x, one at a time. So after this program is completed, it will always output the sum of digits in 0 is s, right? I can confirm this here. So if I input minus 170, we will get the sum of digits in 0 is 8. And the reason for that is we are overwriting the variable x that the user has inputted. So maybe let's give this another name. Let's call this variable u, because this is what the user inputs. And we will then use x as the variable to work with. And in the end, we can output the sum of digits in u is s. which number, minus 170, and we get the correct output. The sum of digits in minus 170 is 8. And if we want, we can even refine this code even further by using the shorthand notation for integer division. This can also be shortened to S plus assigned to D. Okay. Let's try again if we haven't broken anything. It's still working. Right? So this general way of working, starting with the core part of your problem, maybe using predefined values for the variables x or all the input variables that you want to deal with. Get your code working, test all the boundary cases. Does your code also work for negative inputs? Does it work for the input 0? If all of this is fine, you can then add the user inputs, you can add some nice outputs at the end, and you can refine your code. But generally, I would always recommend start with the core of the problem and don't start with user inputs and nicely formatted outputs, because this is really not important for this task here. Now let me add a final note on Boolean expressions within conditionals. As we've seen before, some of the integers and some of the floating point values evaluate to true, whereas others evaluate to false. In the Boolean context, as a general rule, the variable none and the value 0, the integer value 0, evaluate to the Boolean false value, whereas non-zero numbers evaluate to true. So if you have an if-else statement of this form where you say if 0, then this is equivalent to writing if false. So this first expression here will output 0 is false. Whereas if you do the same with a positive integer like 17, or in fact any non-zero integer, minus 17 would work as well, then it will print out true. So 17 evaluates to true. This is sometimes useful in your code because you can save a few characters by exploiting that. For example, here we are checking whether x is a non-zero number. Right? It is much shorter to just type while x, because this will evaluate to true if and only if x is non-zero. Let's run this. Minus 170. Okay, it still works exactly as before. So you can often save comparisons where you check if something is different from 0 or equal to 0 by just using the fact that the integer value 0 evaluates to false and non-zero integers evaluate to true automatically in Python. The general rule for this behavior is written here. If a value resembles a 0 or some empty value, its Boolean interpretation is false, otherwise it is true. If in doubt, you can always check the Boolean representation of a value yourself by using the bool command. Right? So if you convert the integer value 1 to a Boolean variable and then print it out on the console, you will see that the corresponding value is true. Whereas if you convert bool 0, you will get the Boolean representation of false. All right, this brings us to the end of today's lecture. I hope you enjoyed it. And I would like to do a very quick recap. We started off by discussing some general principles of programming. You remember this list of 10 points. Please read it carefully and think about it step by step. What does each of these points actually mean for you? Maybe you want to get a notebook where you can scribble in some things while you start programming, and maybe you want to create a GitHub profile so that you can later share your own codes. Then we started thinking about loops, and the most simple loop in Python is the for loop, which is defined using the for keyword. Then you have some kind of running variable, let's say x, the in keyword, and then we learned about the range function that if you call it with one input argument, let's say n, will produce something that behaves like a list of integers starting from 0. So it goes from 0 up to n-1, and this particularity of starting to count from 0 in Python is very important. The end value n will not be included. Then we have this colon that ends the definition of our for loop, and on the next line, indented to the right level using the tab key, we will have some block of code that will then be executed n times. Sometimes it's not known in advance how many repetitions we want to do of a code block, in which case we use the while command. The while command is typed as follows. It expects a condition that can be checked, like something like this. And again, we have an indented block that will be repeated as long as this running condition is true at the beginning of the while loop. We also learned about conditionals, in particular the if and else keyword. So if some condition is true, let's say is I strictly less than n, then again we will execute an indented block of code. And we learned about else, which will be executed if the condition at the beginning of the if statement evaluates to false. So we might have some other block here. Okay, so this allows us branching our code into different regions which are executed depending on some logical statements. We learned about how to swap two variables using a third temporary variable in Python, and we learned how to sum the digits of a number. Please have a look at this example in particular very carefully and make sure that you understand how we used these two operators here in order to extract the digits of a number one after the other.